Yes.
Hello, sir.
हाँ.
Sir, we have
Uh,
created the test and trend data and the for the brand cross sell, and we just predicted the outcome also, and we
Mm-hmm.
created a submit vector where we view the three file.
Mm.
Uh,
Three
means
vectors or columns.
yes, yes, sir.
हाँ.
So
हाँ.
what is the predicted, what is the churn, and converted, what its probability.
Okay.
So
We also
and
used if-else function.
no, sir. You told us that you are going to teach us now, sir. This was the
Okay.
last, sir.
Okay. Right. So
sir, will you be accepting responses today also?
yes, yes. Why not? अगर आप
Sir,
कर रहे हो तो
because
मैं क्यों नहीं एक्सेप्ट करूंगा?
I- sir, ये prediction वाला part run कर दिया था तो sir hang मतलब system आगे कुछ कर
हाँ हाँ, तो
नहीं
सी दैट इज द रीजन व्हाई आई टोल्ड यू कि आपको ईडीए तक करना है, एक्सप्लोरेटरी डेटा एनालिसिस, लाइक ईडीए प्लस splitting the data into train data and test data. You have to do that step. Now the logistic regression, building the machine learning model, is we will do in the class, and I'll also explain why you are facing, right?
Yes, sir.
Okay.
Sir, is there any way where we can undo a code run executed command?
हाँ, so you rerun the earlier command and the existing command वो undo हो जाएगा.
सर क्योंकि एक्चुअली क्या था ना, वो हमारी इसमें यस नो में देखे था ना चर्न आउटपुट, तो सर
हाँ
उसमें
हाँ.
जब 01 में ट्राई किया ना तो बहुत बार क्या हो रहा था, मतलब ऑनलाइन कोड से यस ही पूरा गायब हो गया, वहां पे एनए आ गया डायरेक्ट, एंट्रीज ही अवेलेबल नहीं आई, तो फिर सर कंट्रोल जेड से वगैरह हुआ ही नहीं वो, और फिर उसके बाद वो कोड ही चला गया,
ठीक है.
तो
So
पूरा
प्रतीक
डिले ही
हम
हो
वो
गया सर.
जब, हाँ हाँ हाँ.
सर
So
ऐसा पर हो सकता है.
so Pratik, you show me the screen. Yeah, and this is outside the class. See, Manish was also
Yes, sir.
facing some problem, and then we discussed, and then we sorted that out. Okay. So
Yes,
we will discuss. So you show me what problem you are facing, and we'll discuss and find out a solution. ठीक
ओके
है.
सर.
ओके. बेसिकली आपको ओवरराइट करना है व्हाट यू हैव डन रीसेंट कोड्स का. तो यू
यस सर.
हैव टू रन द अर्लियर कमांड्स and you will come back to the same stage again.
ओके सर.
ठीक है.
सर हेलो सर.
यस.
सर जब मैंने मिसिंग वैल्यूज के लिए चेक करा था तो किसी एक वेरिएबल में मिसिंग वैल्यूज आई थी, तो वो वाला पार्ट फिर
यस.
कैसे आगे करते हैं?
हाँ हाँ. So for that's again, see what the all the problems that you guys are facing, I am aware what kind of problems you will face. Okay. And that is the reason why in the second data set there are missing values. In the first data set, just to not get confused, there was no missing values, and so in the second data set, so we have increased the complexity slightly, and there are missing values. So I will show in the class how to handle such missing values when we move to that data set. For this data set, we will run 3 to 4 machine learning models, evaluate each of those models, look at their accuracy, and then move to that particular data set. Is that fine?
यस सर, यस सर.
Okay.
थैंक.
Right. So what we did in the last class, we created a data frame using this particular data.frame command. Okay. We captured the customer ID. We have built the model on trained data, and we are testing the model on the test data. So we have capturing the customer ID, the name would be this in that particular data frame, and we are capturing that data frame, test data frame. We have the actual values and from the test data set, we have calculated the probability. Okay, and that values are stored in this particular vector. Okay, so what we are doing, we are assigning that vector to this particular name. So these three values will get stored in the data frame. So we have run this command, and then we are just looking at what data has been stored in this particular data set. So we have customer ID, and this has been picked up from the test data set. Right, so from this data set, we have picked up this customer ID and assigned it to a new variable. The other column that we picked up is this, and we have named that as Y actual. Okay, and this probability value we have picked up from this vector. Okay, now we have this probability value, and based on probability, we would like to classify whether the customer would accept the cross-sell offer or whether the customer would reject. So what is the general threshold we take whenever we are handling such kind of problem? Yes.
The 0.5.
Right. So we take 0.5 as the threshold value. Right. So if the probability is
Hello,
below
sir.
0.5, yes.
Sir,
Yes.
do we necessarily take the 0.5?
No, not necessarily. Again, this depends on the data. This depends on your behavior of the data. This depends on the sensitivity of the data. This depends on the imbalance in the data. So there are various reasons, various aspects. This depends on experience also, right? So you number of times observe and look at the probability and look at whether the person is accepting the offer or not. Okay, but generally accepted norm is 0.5 for a regular business problem.
And sir, if
Let us
we have
say, yeah, Manish, let us say if there is, we are talking about financial fraud. Okay,
okay,
then probability in that context, based on that particular problem, based on that particular data, based on experience, the probability value changes. Okay,
yes,
yes,
sir.
but our assumption is odds ratio. Okay, the odds of an event occurring, there is no bias. Okay, each event which is accepting the offer and not accepting the offer, the chance of that event
Ah,
happening is 0.5.
yes, sir.
Okay, so based from that premise, we are taking the threshold as 0.5. The moment we shift that to 0.6, we are saying that the probability is conditional. Okay, we are saying that the both of them do not have an equal chance.
Okay, sir.
Yes.
So, sir, we in this way can manipulate the accuracy of model also, sir.
Yes, yes. Again, if you want to go into such details, I would recommend, I have written one blog on evaluating classification models. And there are at least 17 parameters that are used to evaluate a classification model. Okay. And in that, there is this aspect called receiver operating characteristics curve. Right now, that curve actually takes different thresholds like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.10, and 1. Okay, and based on that, right, the moment you shift the probability from 0.5 to 0.6, okay,
Sir, it's more like to finding the K-mean where the elbow is achieved. Is it similar to
No,
that?
not, let us not link K means, but I'll just explain. Okay, so let us take 5 probabilities. Point ये क्या हो गया इसमें? Let us take 5 probabilities. 0.4, 0.5, 0.6, 0.55, 0.3. Let us say our threshold is 0.5 and then our threshold is 0.6. Now, if our threshold is 0.5, this becomes 0, this becomes 0, this becomes 1, this becomes 1, and this also becomes 1. Okay, now our threshold, we have decided that the threshold is, rather than 0.5, we are saying the threshold is 0.6. Now this is 0, this is also 0, greater than or less than, okay. Now 0.51, this is 0 now. 0.6, this is 0. We are saying greater than 0.6, not greater than equal to. So greater than 0.6. And again, this becomes 0. Let us say this is 0.62. So this remains 1. Now, this has changed and this has changed. Okay. Now all these,
Yes, sir.
if you, right. So the moment, the shift that you make, you calculate the transition. What is the change? And then you look at the accuracy of the outcome. Okay, so now there are parameters to evaluate this. We'll discuss that, some of the parameters. We start with confusion matrix, then you have true positive rate, false positive rate,
True negative.
sensitivity, right? ये जो whatever that we are listening about corona also, na corona test, it
Yes, sir.
gives false positive result. It is actually, see, what is the outcome in corona test? Either you are positive or negative.
Yes, sir.
Okay, again, that is like a binary outcome, and exactly the same problem what we are discussing here, right? So, and in medical science, such kind of problems, right, you require very high confidence intervals, and then you also look at those confusion matrix. There's 4 parameters. You look at type 1 error, type 2 error. You want to avoid true negatives, right? Let us say the person was corona negative, but the test is showing positive. So you want to avoid such. Okay, so I will try to discuss those elements, but in detail, if you want, what are the all these 17 parameters? I would there is a detailed blog that I have written. You can go through, and then there are to get those values also you need only 1 or 2 commands. Okay, so we'll discuss that when we come to that. Okay, so
Okay.
now based, yeah. So I hope Manish, I have answered your question,
Yes,
and
yes,
right. So if you still want to discuss, we can discuss this outside the class.
got it, sir.
Okay, right? Now, since we are using push कर दिए. So we want to say if the probability is less than 0.5, classify this as 0, and if it is greater than 0.5, classify this as 1. Okay, so in that case what we do, we use if else function, right? So if else, if probability is 0.5, assign this as 0, or greater than 0.5, assign this as 1, right? So the command for that is so we are using if else function for which vector? Prediction. If it is greater than 0.5, we are saying 1. Assign that value as 1. If it is otherwise or else, 0. Now let us say, rather than in our data set, this particular data set, the outcome value is taking 0 or 1. Now rather than taking 0 or 1, the outcome variable is taking y and n, yes and no, rather than taking 1 or 0. How will this command change? बताइए.
So we'll
Yes.
put instead of 1 and 0, y.
So instead of giving input as 1 or 0, we will give input as y or n. Now the reason I am telling you this is, sometimes in the outcome variable, rather than getting 1 or 0 values, you will get yes or no, or y or n, or what was the value that Titanic data set was taking? It was 1 0 or survived, not survived. Now if the
Survived,
value
not survived.
so then in that case here, those survived, not survived will come here. I hope there is a clarity on this. Okay, so run this command. I am copying that command into the chat box. Run this command. Yes, Chandrasekhar. Chandrasekhar, you want to?
Sir, it's a mistake on my part, sir. I have to click the chat box and I mistakenly did this.
Okay, okay, okay. Give this vector, okay, what values it is taking, and also look at the table values of this vector. Use command table for this predicted dot classes and tell me the distribution, proportion of ones and zeros in that particular vector.
Sir, 0 is 1274 and 1 is 65. Hello, sir. Am I audible?
Yes.
Sir, 0 is 1274 and 1 is 65.
Okay. Okay. Others are getting these values?
They're slightly different.
Huh.
It's slightly different. It could be because of the seed which I
Yes.
said.
Yes. Yes. So if you had, okay. So see, everyone please set the seed to 1, 2, 3. I'll just check what I have so that we get similar results. 1, 2, 3. So this set dot seed, everyone set to 1, 2, 3 and rerun the command.
Sir, mine is already in 1 to 3 only.
So that's fine. So Pratik and others in the class, right? Set your seed to 1, 2, 3. So I am viewing this data set. Okay, you are taking 0 and 1 values. And we are just looking at the table of this. And we are getting this output. Right? So this is our prediction.
Different, little bit different, sir.
So
same here.
Yes. So thoda sa difference is fine. Okay?
Yes.
Yeah.
So it's like 1 to 79 and 69.
1 to 79 and 69. Just check whether
Sir,
you are taking. Yes.
Also could be because of the classification between train and test data. 0.7 and 0.3 I took.
No. Just see whether you are taking the exact same this variables. That is fine. This predictor variables in the second regression model that we have. So I am taking age, balance, month, duration, campaign, and
No, sir,
contact.
actually the variables are different. Sir, can you paste the variable code? Because I pasted it according to the seed of 80.
Okay. So I'm pasting the model. Okay, now you have this also, prediction classes, right? Now to this particular data frame, please add here another column. And with a name Y classification, Y underscore classification. Can you do that? And if we have to use the same command again, what will you do?
So submit.
So this submit, Tanishq, it is just a name. I hope you are appreciating that. The only thing that you will add to this particular code, I am just.
So after Y probe, we will add another variable, sir.
Exactly, right? So this command we used for those 3 variables. I have posted the command in the chat box. Okay, we've submit ignore kar do. Right now to this particular command, what we want to name it as Y underscore class. So yahan pe after my log prediction you will give comma Y underscore class, that is the name we would like to give, equals to the name of that vector predicted dot classes, and again you will run that command. Please run the command. Yes, of course, I'll post that code. So have you run the command? Or are you guys waiting more for me to paste it?
Yes, sir, run.
Okay.
Done, sir.
Right. And give me the run the table for the Y underscore class and give me the output. So I'm pasting the code. So we have added Y underscore class equals predicted dot classes. So what we have done, we have added one more additional column to the data frame, one more additional vector to the data frame.
So it will give the 4 column customer ID, Y actual, Y probability, and Y class.
Yes, yes. Okay, so now we have done with our calculation of prediction of the outcome, right? We are making a prediction whether that customer will accept the offer or not for the test data set. Okay, now what we have to do is we have to evaluate the model. How do you evaluate the model? आप लॉजिस्टिक रिग्रेशन का इवैल्यूएशन कैसे करते हो?
Sir, using confusion matrix.
Yes, so you use confusion matrix. This could be prediction, right? The axis can change, and this is the actual. Okay, and then you put some values x, y, a, b, c, d, right? And then you calculate the accuracy. Now, which one would be accurately classified? Which cell? A, B में A would be correct classification, actual and prediction, and D would be actual, I mean correctly classified, and these values would be wrongly classified. Right? How do you evaluate a regression model? This is logistic regression classification model. How do you evaluate a regression model or when you are trying to predict continuous variable? How do you evaluate that?
Accuracy, sir.
Accuracy of what?
So how many are correctly predicted? So true positive and true negative.
Yes.
Divided by total number of predictions.
That is, Tanishk, I said that is for classification. I am asking, let us say you are dealing with continuous variable. You are trying to predict continuous variable. Yes, Manish.
Sir, for the regression, we see the error. The error will be minimum, then the better will be the regression model.
So absolute error or what? What do you look at?
Mean map, sir. Absolute error, sir.
So this is your model, and this is your actual value, and this is error. Okay. So let us say that this is x and this is x hat. Okay. So what you do? You take root mean square of error. Is that fine?
Yes,
so
sir.
Right, you take the square of this. Now you calculate these errors for all the values. Right, you square it and again take a square root. That gives you the goodness of your fit for a regression model. Okay. So let us now, this also, what I have done, I am not using a very ready-made package. There is one package, caret, there is one command called information value. And if you give the command as confusion matrix, it gives you almost all the 17 variables. Now in this case, we are just using formulas, step-by-step formulas to calculate the accuracy rather than using that command. And I'll also probably in the second example, second data set, we will use that command also. But this also gives you an idea as to how a particular package is built in R, right? So what you do, you write series of steps or formulas or equations in the package, and in the front end you use that command and it gives you the value. Okay, so we want to calculate the or tabulate the confusion matrix. But before that, you would like to extract this in lot of these competitions. They ask you to submit your actual outcome and your predicted outcome, which means I'll just, okay, I have not run that command. Now what they ask in competitions, ये जो Kaggle पे competition होता है, GitHub पे और other competitions, analytics competition, what they ask you in the form of submission, they ask you to make a CSV file submission, and they ask you to pick up that customer ID. They ask you to pick up the Y actual from the data set, and then they ask you to, sometimes they ask the probability, sometimes they don't ask the probability, and they ask the classification. What is your prediction? Okay, so in that case, you would like to extract the CSV file. Okay, and the command for writing a CSV file or importing a CSV file from your data frame is write.csv. So this is your command. So you are creating a CSV file for which data frame? Submit data frame. This is just a name. So submit, then you would like to give some name. So that is the file name equals within double quotes. Okay, you give some name. You can give whatever you would like to give. Let us say your logistic model, logistic regression model, whatever name that you would like to give here. The file extension is .csv, double quotes, okay, then comma, and then row names equal to false. You would not like to give names to the rows, right? So then if you run this command and go back to your project directory, in that project directory there will be a CSV file named tmc logistic1. Okay, so run this command and go back and see whether you are getting this file or not.
Yes, sir. Got it, sir.
Yes, great. So I'm posting this command. So let us now tabulate or create a confusion matrix. Okay, now so what we are doing, we are just tabulating the two values, y actual comma y predicted. Run this command. Yes.
Sir, it's a form of confusion matrix 0 1 0 1 1 1 5 3, the value given, sir.
Right. Okay. So let us assign this table to some name. We give some name. Classification. Okay. And run this command. You will get output. Okay. Now you would like to calculate the accuracy of the prediction. Now when we are talking about the prediction in the confusion matrix, okay, A plus D divide by A plus B plus C plus D would give me the accuracy,
Yes, sir.
which means sum of the diagonals and sum of the entire classification will give me the accuracy. So the same thing I will do here. Okay. So what I am doing, I will sum of what? Diagonal elements. So the way to write is DIAG classification. Within bracket and close the bracket. And then you need to divide that by sum of classification. You can give some name, let us say accuracy test. This will give you the prediction accuracy. The command for that I am copying here. And let me know the proportion of the accuracy.
So 90.28.
Right. Yeah. So around that
Sir,
number
in
you
my
will
case,
get.
88.7.
Yeah. Some variation would be there. Now, what if I want to calculate the error rate, error in prediction or misclassification error? What would I do?
Sir, we will select
Opposite.
the opposite.
1 minus accuracy test. So do that. What is the value that you are getting?
0.0971.
right? So that is the error in prediction, in your error in prediction. So you would like to improve on this error, right? Or improve your prediction accuracy. At this stage, it is around 89 to 90%, and you would like to improve this prediction accuracy. And that is why probably we would explore other algorithms. And if we use other algorithms, we will see whether we are able to increase the prediction accuracy or not. Okay, so we have used logistic regression. Now we will move to decision trees. Now, before that, just help me understand whether you have heard this term black box models or black box algorithm, and what is your meaning of black box?
Sir, it is, I think, kind of like we do in supervised learning, that we don't know on what method what is the underlying algorithm, how the machine is classifying things. So put an input and get an output, but we don't know what is happening in between.
So here you are exactly right. You don't know what is happening, and you are giving an output, and you are getting an you are giving an input, and you are getting an output. You don't know what is the underlying mechanism. Okay, so so such algorithms are called as black box algorithms. Okay, which means you when you use those algorithms, okay, but you don't know which are the variables important, which data is important, okay, and how do you explain the outcome. Okay, now in logistic regression we know, okay, these are the 4-5 variables which are important, and these are the 4-5 variables explaining the outcome in the dependent variable. Okay, so all these 8-9 algorithms that I have spoken about, okay, some of these algorithms are considered to be black box artificial neural. So you have input layer, hidden layer, and you have an output layer, and you don't know what is happening in the hidden layer. Okay, so those algorithms are considered to be black box. Now, all these models that we are building, one of the most important aspect, especially for top management, they don't know what is, how a model is built, how it is deployed, or how it is happening. The only question they ask is, can you explain this model to me? Okay, and in that context, the in practice generally, okay, only models which allows you to explain the importance of variables in the, or which allows you to explain the changes in the outcome variable, probably those variables, those algorithms come in handy. And one of that algorithm is logistic regression. It allows you to explain the variation in the outcome variable. Then the second algorithm is your decision tree. Okay, let me ask you this question. Now, in a lot of companies are coming for placements. What is your criteria of opting for a particular, whether you will appear for the interview or not? Yes. Whether you will apply for that
package.
So main criteria will be domain
okay
first, then
package. So give me some threshold for the package. Give me some threshold for the package.
so more than 12.
Let us say 8 lakhs per annum. Okay, if the package is greater than 8 lakhs per annum, you say yes, no, and it terminates here. Right, so the most important variable in your decision to apply is package. Now within package, now what is the next criteria? So Harsh was telling what area or job profile?
The domain also, yeah.
So then domain, it falls into your domain, yes. It doesn't fall into your domain, no. It terminates here. What else after this? What else? और कुछ बताओ?
Then job profile, sir.
Let us say job profile matches your job profile, yes. Doesn't match your job profile, no. What else?
Brand name.
Brand name, right? It is below this, below yes. So you are saying brand name, yes and no. This is how decision tree operates. Okay, it splits up this sample into these decision making attributes. Okay, now in decision tree, this is called as root node. Wherever it terminates, this is called as terminal node. Let us say this entire thing would be called as branch. This one thing would be called as leaf in the decision tree. Okay, now when we run this particular algorithm in the form of output, we get this kind of tree. Now, on what basis this is split up? Okay, there are two measures. One is Gini index. The other is entropy. Now there is a formula for this. I will share this formula, but I'll important and relevant when you are doing this. So Gini index and entropy. This Gini index is how much variance a particular variable is explaining when you are splitting this into yes or no, is what your Gini index. The another terminology for Gini index is your information gain or information value. How much variance this particular variable is capturing when you are taking that decision. Okay, so and in that model, based on Gini index, okay, you can look at which variables are important for you. You can also look at the decision tree and look at the variable which are important in your decision tree. So I hope there is now see decision tree in itself to understand an algorithm. Okay, it takes probably 2 to 3 hours, but to run that algorithm and to understand what's happening in the decision tree, I have tried to explain that in brief. Okay, so let us run the decision tree algorithm and then look at the accuracy, classification accuracy, decision tree, and we will see whether decision tree is better than logistic regression or it is more or less same or it is, so we'll see what is the use of decision tree. In some cases, right, logistic, most of the times logistic regression gives you the accuracy. Let us say if there is if data violates normality assumption, under such circumstances, these algorithms give you kind of a better accuracy in terms of results. Okay, so for decision tree, and viewing that decision tree, you will need some 3-4 additional packages. Okay, and those packages are, so please install these packages. So this is the R part is your decision tree. Then you would like to plot that decision tree. For plotting that, you also need a rattle package, which is like a package which is used for graphs, and install this R color brewer. Okay, this will kind of when we run the command, I'll explain why we use this particular package, just to beautify that graph. Okay, so use this option here, install, and install these 4 packages, and recall this. If these 3 or 4 libraries run successfully, which means you have installed that these 4 packages successfully. So just do this. If you want, I can post the command in the chat box. Do this, and I'll just take a break.
Sir, I'm
Yes.
facing the error in.
I'm looking at the error. Others are also facing similar kind of error.
Sir, I'm not getting error, but I'm getting warning messages.
Warning messages you can ignore.
Yes, sir. Same.
Huh,
Warning message.
huh. So,
Sir, it might be because of the R version.
it could be. I'm just looking at the error message also. Try removing this particular document from your directory. Manish. Just run once again the library rattle package.
Sir, I tried twice, sir, and same result I'm getting.
What is the version of R Studio you are using?
3.6. 3.6, sir.
R Studio version.
Yes, sir.
I think you will have to. नहीं वो नहीं रहता है. Just see यहाँ पे जाकर के. So 1.3, I think this is the most recent version.
1.3.10.
You're using the same thing?
Same, sir.
Okay, and what about the base R?
Base R, I think 3.6, sir.
Okay, okay. So just try updating that, but I will discuss that. Okay, Manish?
Okay, sir.
I think your decision tree at least would run. This is related to the visualization of that decision tree.
Okay, sir.
Okay, now look at this. Command for machine learning algorithm. What is different between that logistic regression and decision tree command here? Difference क्या है बताओ मुझे सिर्फ. Between this command, I'm just pasting that in the chat box for better. किधर गया? This command and
Instead of family, it's method.
And this command. Focus on the function that you are using. Okay, for logistic regression, what you are using here is GLM. That is the command for generalized linear model. And then only thing that you are doing here is, okay, this is a binomial, this follows binomial distribution 1, 0 outcome. Okay, now see the difference here. This GLM is just becoming R part, which is your decision tree. And this is what happens for all kinds of algorithms. Okay, only the name will change when you are writing the code, right? So there are various, I would say, let us see whether I have that or not here with me. Are you able to see this PPT?
Yes, sir.
Yes, sir.
Now, when people are claiming that they are doing machine learning, or they are data scientists, or they are building machine learning models, okay, this is what they are doing. One line of command of that particular machine learning algorithm. Yes, of course, it involves all those steps that we have done. Okay, but in the end, right, the code does everything for us. Okay, and for these algorithms or models, you need just one single line of code, and you just need to appreciate these differences. Okay, now अब ये GLM से यहाँ पे you went to decision tree. This is one of the algorithm or package R part. Now let us say from decision tree you move to random forest. So सिर्फ यहाँ पे random forest उसका whatever the command name is, let us say the command name is random forest, the other thing will remain the same, and that will build you random forest model. Let us say you are using support vector machine. The only thing that will change here is SVM. The other line of commands will remain the same. I hope there is an appreciation of this. Right? So you will find in practice.
Can you explain?
What I should repeat what I explained, Manish.
Actually, sir, I got disconnected
Okay.
momentarily. So can you repeat?
Wait. So what I am telling is, let us say logistic regression, decision trees, random forest, support vector machines. Okay. We are using GLM for building logistic regression. We are giving the formula.
Yes,
the
sir.
outcome variable is y tilde and your independent variable.
Yes, sir.
We are using which data to use? We are using data equal to test, train, okay. And what we are doing, we are telling that this is a classification problem. So family for a GLM, it is family equal to binomial.
Classification.
Right? Binomial, right? Family equal to.
Yes.
Now we want to build decision tree. Okay. Now the command for that is R part. Within bracket, this formula remains the same thing here. This again remains the same here. The only thing that we are giving here is, okay, this is classification problem. The same thing for random forest, okay. The command for that is random forest. Within bracket, the formula remains the same. The data remains the same. And you say, okay, this is classification. Support vector machine, the command is SVM. Within bracket, you give command here, you give command here, and you run the command. Right? So basically what you are telling, okay, this command is changing. We want to build random forest. You give the name random forest. You would like to build support vector machines. You give support vector machine as a command, and you build a model for that. Now you use that model, okay, to calculate y for the test data set. Again, the procedure, you use the command predict. Right? You have new data test. You use the model. You're using predict function. You have a model. This is the name of the model. You are predicting for the new data. New data equals to test. And you want classification. Okay, and this will give more. You use for decision trees. You use for random forest. You use for support vector machine, and you calculate. Then you again evaluate. So the process remains the same. Or there are other algorithms like KNN, right? Nav bias. There are artificial neural network. The same approach. Okay, only in the context of artificial, there's slight difference in neural networks, but the entire approach remains the same. I hope it kind of gives you a comfort. Okay, it is not very difficult to use all these algorithms when you are trying to run the command in R. Now the next thing when you do this is to understand very minute details of all these algorithms to understand what's happening in the back end. What is the mechanism? Okay, and when you appear for these kind of analytics role or machine learning interview roles, that is what they will ask. They will ask you what is the mechanism, what's happening in the algorithm, how is the algorithm coming up with such values. So that is what they will ask. Okay, I have shared some of those questions continuously with you guys. You can look at those, critically ask, you can come back and discuss with me. So all these things can happen. Okay, so let us start building our decision tree model. Right, so see this command. As I said, this is the name of the decision tree model. This is the command. This is the formula. You can write here formula equals, or you can just directly write y tilde full stop and comma. This implies, this denotation implies it is taking all the variables in the data set to build the decision tree. Okay, and method is you're saying it is classification, which means you would like to classify whether he will accept the deposit or whether he will not accept the deposit. So run this command. So if you view the model, all the information about the model will be available. Okay, one of the most important information that we would like to look at is this variable importance, and I'll show how that is to be looked into. Okay, then you would like to visualize this plot, visualize the decision tree. The command for that is just plot. Now in this you will, if you run this command, you will observe it is a very blank tree. Now you would like to include text in that tree. So you use command text for that particular model and run the command, and you will get the splitting variables on the decision tree. Now again, this looks very complex. It doesn't look very clear hodgepodge visualization. So you, from this R color brewer, okay, you use this function fancy R part plot. I'll run this. So you have kind of getting a very organized, and with colors you are getting a decision tree. Now I will export this decision tree. This is how your decision tree looks. Okay, so the first splitting point is the duration of the call. Okay, so this variable is important for us. Now the second splitting point is the previous outcome, and within that again duration. Then the other variables which are important is your age here, okay, then your job type, right, month, the P days within that. Okay, so these are the variables which are important for explaining the outcome. Okay, and these importance has been calculated using Gini index, and the way to look at the importance of that variable is Now this particular model, which we have named it as fit, okay, it has various information. If we look at the model summary or view fit, this variable dot importance, you would like to look at these values. So your model name is fit. Within that, variable importance has been stored.
Sir,
yes,
during creation of decision tree, has the algorithm already calculated information gain and entropy and assigned weight to the various elements?
Yes. So you run this fit dollar variable dot importance. Okay, there are various parameters like complexity parameters and all those things. Yeah, so just run this command and tell me the output, what output you are getting.
Sir, I think there is some very digits are coming, but I don't know what is it indicates, sir.
I'll explain.
0153.
Yeah. So I'm running this command. This is the digit. This is the values you are getting.
Yes, sir.
Approximately same, sir.
Right. So this is your Gini index or variable importance. Which variable is explaining the variance in your outcome variable? Okay, if you want the formula for Gini index, I'll share this. So this is the Gini index formula. This is the entropy formula, but generally Gini index is taken into consideration. Now these numbers is the information gain. Now in your decision to apply for a particular organization in campus interview, the most important variance that is getting captured in your decision whether you will apply or not apply is the package, right? So when you look at the Gini index or information gain, so package will come at the top here. I hope there is a clarity now. So for us, duration has become the most important aspect when you are splitting your decisions. Look at this here. See this in the visualization also, the most important variable is your duration. The second variable is P outcome. So P outcome is the second node. Okay, then you have day. So this day is coming here in your decision tree. Then month. So month is coming here. Okay, then is your P days. P days here, and your job here, and then your age. Okay, yeah, so age is also so and then it is kind of terminating here the decision tree. Okay, now what you are doing is you are using all the variables to build your decision tree. So what the next step is, probably you will look at this decision tree and variable importance value, and we are seeing here, okay, these based on the decision tree and based on the Gini value, these variables are important. Another value to look at is the complexity parameter, and you can prune the tree. What you are doing is you are looking at just the same way In logistic regression, first you take all the variables, or you look at the correlation table and look at the most important variables and use those variables for building the model. So same thing we do, and we conclude these are the most important variables for building the decision tree. Okay, so what you do here now, rather than using all the variables, what you can do is you can look at this model, look at the accuracy of the model, evaluate the model, and again come back and change the variable. The other way we are saying, okay, these are the variables which are important to us, and we will, rather than taking all the variables, we will use y tilde and use these variables to build our second decision tree. Is that fine with everyone?
Yes.
Okay, so then this particular code so you give some name fit1 because this is different name, and here we have duration plus p outcome ये मैं कैसे हटाऊं, ये जो आ रहा है तो यहाँ पे हेलो
सर इंटर करके
एंटर नहीं तो वो आगे बढ़ेगा ना एंटर नहीं वो ये जो ये आ गया ना तो वो आगे वाला डिलीट हो जाता है
सर एक्चुअल में कॉमा मिस हो गया आपसे तो वो कंटिन्यू
नहीं ये जो दिख रहा है ना ये अंडरस्कोर ये देयर इज सम वे टू ठीक है आगे वाला डिलीट हो जाता है नहीं तो ठीक है पी आउटकम देन डे देन मंथ देन एज then p days and then job comma data equal to train ये ऐसा होता है ना and method equal to class so this becomes your second decision tree run this command
Sir, try pressing insert.
insert where it is हाँ
Sir.
हाँ हो गया हर्ष थैंक यू नहीं ओके हाँ all right so you have run the second decision tree now so let us say decision tree we give some name we are calculating the prediction for the decision tree we are using predict function the way we use for logistic regression we are giving the model name fit1 in earlier case we gave the model of logistic regression model name okay data new data or you can just give name test also equal to test comma type equal to class close the bracket and this will give you the value of your classification. You can view decision tree. Okay, and these values will be 0, 0, 0, 1, 1, something on these lines. So do this. I'll just copy the command. ये तो मैंने कर दिया है.
Got it, sir.
Okay, आपको prediction मिल रहा है?
Sir.
Right, now again for submission what you will do, you will pick up the customer ID, you will create a new data frame. You can give something new name also, submit 1, submit 2, submit 3, or submit underscore decision tree, something along those lines. Use data.frame, just the way we use for logistic regression. Within bracket, customer ID, first column, second column is your Y. You will call this as Y actual, Y underscore actual. Third column would be Y underscore classification, and the name for that would be whatever name that you have given to this particular code. In this case, I have given prediction. Here, the same thing. Here I have given. Okay, I run the command. I'm using the same name, and I will use again the same command, write CSV, and this gives me the submission for my decision tree. Okay, now these calculation, what you have to do, you have to just copy this command from the above. Okay, if you maintain the same name here, okay, the way you have maintained in the above logistic regression example, you just have to copy and paste this command and run this command. I hope there is a clarity on this. Okay. So you will now create that submit file and calculate the accuracy. You will have to just copy the command from the above, maintain the same name of all the vectors in the submit file. In that case, you will have to just copy the command and run the command. It will give you the results.
Sir, for the submit decision tree, you have taken just customer ID, Y actual and Y class. There
Yes,
is no
yes.
probability, sir.
So we did not calculate probability. We directly asked the algorithm to give us the classification.
Okay, sir.
Right.
Sir, what are we naming this prediction in our submit file?
Y underscore class. That is the classification. Okay.
Okay.
This, yes. Harsh, I'm just look at the selection.
Yes, sir, got it.
Yeah. If you have maintained the same name, classification or accuracy calculate करने के लिए just copy the command from the above and paste it here. It will give you the accuracy results. Okay, so we are formally closing this class, but if you have any questions, I am here to answer. Otherwise, if you don't have any question, you are free to leave the class.
Sir, accuracy improved in this case.
Yes, how much?
Not much, just 1 or 2%.
Yes, yes, yes.
So
Yes.
can you show the code after we view the decision tree? After we predicted using fit1.
So this is the one you are asking for, Prateek?
Yes, sir. So new data we no
हाँ,
sir
yes,
above
so
one.
हाँ, उसके ऊपर वाला.
Okay, sir. Okay, sir. Now prediction.
This is just a name. अभी मैंने यहाँ use किया. You can use the same name. Otherwise, you can say decision tree prediction, just to for more clarity purposes. तो अगर आपने यहाँ डिसीजन ट्री प्रिडिक्शन नाम दिया है तो यहाँ पे डिसीजन ट्री प्रिडिक्शन आएगा.
Sir, my accuracy decreases, sir.
What was your accuracy earlier? And you are using the same variables which we are using?
Yes,
Your
sir.
duration, P outcome, day, month, age, P days, and job. You are
Yes,
using
sir.
the same seed, set dot seed 1, 2, 3.
Yes, sir. Some previous accuracy was 90%. Now it is 88, sir. 88%.
Acha.
Sir, I have used some more factor. That's why I think I'm getting more
Which
accurate.
other factors you are using?
Sir, actually, I have already posted in the chat box, sir. The total code, sir.
Yeah. See, see, then let me just ask you, what do you mean by parsimonious model? Have you heard of
Sir,
this
I
term?
don't remember.
Huh?
Yes, I heard, but I don't remember now, sir.
Okay. Let us say with 5 variables, you explain 90% of the variance in the dependent variable. Okay. With 10 variables, you explain 95% of the variance. Which model you will prefer?
Sir, with more variable.
Others?
So that
Okay. Yes, others, if you would like to come in.
Yes,
Sir,
sir.
I would prefer
Sir, less variables.
90% with 5 variables.
Right. So this model is explaining more variance, but with more number of variables. This model is explaining with less number of. So a model which explains significant amount of variance in your outcome variable with lesser number of or optimized number of variables, you call that as parsimonious model. And why this is important? Now imagine in practice, you would like to increase the cross-sell acceptance. Now to increase the cross-sell acceptance, in this model, you will focus on 5 parameters. However, in this model, you will have to focus on 10 parameters. Right? And generally managers prefer less and less number of parameters to control for to impact their business outcomes. And that is why we need parsimonious model. Now all these competitions, these competitions don't look at whether your model is implementable in practice or whether it adds to complexity or not. So those constraints they don't give. But you speak to a lot of analytics head and data science head, okay, they will say, agar if the model has more than 6 to 7 or 8 variables, they say, okay, can you reduce the number of variables? We are fine with less number of accuracy, but we want less variables. We want parsimonious model. We want less number of variables explaining larger proportion of variance in the outcome variable. And that's how we can impact the business. That's how we can reduce the churn by controlling for those variables, for manipulating those variables, changing the practice so that it influences your those independent variables, which is explaining larger proportion of your outcome variable. Right? So in practice, you should prefer more parsimonious model as compared to prediction accuracy. Now, in competitions, they only focus on prediction accuracy, just to give you the idea. So whichever model which gives you better accuracy, you can go for that. I hope I have answered that question. Yes. Yes.
Yes, sir. I have a question. How do we come to know that this much variable is optimized? So should we go for trial and error, or just is
Yeah. So see
there any code or is method?
yes. See in decision tree, I have shown you one of the aspect is your information. You look at visualized decision trees. That is one way. In logistic regression, okay, you look at the regression coefficient, okay, how much it is influencing, and significance level. Okay, then again you also look at the accuracy, the outcome of the model, right? Up initially you again, this would be trial and error. You start with 4 variables, you add the 5th variable, okay, and after adding 5th variable there is only 1% increase in the prediction accuracy. Okay, then probably you would have to think, okay, do I need to include that variable into my model? So incremental variance explained. Okay, you look at that value. So as I said, again, this would be trial error. There are other factors like in decision tree, it would be the Gini index or information gain. But there will be some black box algorithms which will not tell you anything. And we will look at random forest. Random forest is considered as the black box algorithm.
Okay, sir.
Right.
Thank you, sir.
Yes. So we should I close?
Yes, sir.
Okay.
Thank you, sir.
Thank you.